So what if the secret to making your brain, like biologically 2 years younger, isn't a crossword puzzle or, going for a 5-mile run?
Right.
What if it's actually just picking up something incredibly heavy and then putting it back down?
Yeah, which is kind of wild to think about.
It really is, because for years, the gold standard advice for anyone listening to this who wants to maintain their cognitive longevity has been largely cardiovascular.
Exactly, yeah. We always associate aerobic exertion like running or cycling with oxygenating the blood and preserving neural tissue.
But today we're doing a deep dive that really tests the limits of that whole paradigm. We're looking at a brand new, just totally fascinating paper from February 2026.
Yes, published in the journal GeroScience.
Right. It's titled Randomized Controlled Trial of Resistance Exercise and Brain Aging Clocks. So we're basically finding out if heavy resistance training can actively reverse the aging process of your brain.
Which is a huge claim, obviously.
Okay, let's unpack this.
Yeah.
Because we aren't just looking at regular brain scans here, right?
No, not at all. What's fascinating here is the methodology they used. They didn't just have a radiologist look at a static MRI and check for, like, gray matter atrophy.
Right, no humans eyeballing it.
Exactly. They used AI-driven brain clocks. And to even build that, the researchers had to figure out what a normal aging brain actually looks like from a purely mathematical standpoint.
Which sounds incredibly complicated.
Oh, it is. So they took this entirely separate data set of 2,433 healthy adults, a huge age range, and they ran resting state functional MRI scans on them.
And resting state just means, like, lying there doing nothing, right?
Yeah, exactly. You just lie still. You're not doing a puzzle or reading. The scan just maps how all the different regions of your brain communicate and, synchronize with each other at baseline.
Wow. Okay, so they have this massive data set of 2,000 plus brains just hanging out.
Right. And from that, they trained a machine learning model on 6,670 distinct functional connectivity features.
That's a lot of features. It's massive. And the algorithm basically learned to recognize the subtle, complex patterns of neural degradation that happen as we age. So it created this highly sensitive biological clock.
Okay, so they built the ultimate AI brain age detector. But to see if lifting weights actually works, we have to look at the humans doing the heavy lifting.
Yes, the clinical application.
Right, which brings us to the LISA trial. And LISA stands for Live Active Successful Aging.
It's a great acronym.
It really is.
Yeah.
So for the listeners, the design here isolates a very specific group. They took 309 older adults, all between the ages of 62 and 70.
Which is such a critical biological window, right before more severe cognitive decline typically starts.
Exactly. And they split these folks into 3 groups for a full year. So first you have the Heavy Resistance Training Group, or HRT. They did 3 supervised sessions of heavy lifting a week.
Real heavy lifting.
Yeah, pushing it. Then you have the Moderate Intensity Training Group, the MIT group. They just did 1 supervised session plus 2 home-based sessions with lighter weights. Right, mostly bands and body weight at home.
And then, of course, the non-exercise control group. They were just asked to keep their normal routines, which was like less than 1 hour of strenuous activity a week.
And doing this for a full year is exceptionally rigorous. Most exercise science studies barely last, like, 12 weeks.
Right. A year is a huge commitment, but the timeline of the brain scans is really the crucial part here.
Yeah, absolutely. So they scanned everyone at the start to get a baseline. Then they scanned them again at the 1-year mark, right when the intervention ended.
But they didn't stop there.
No, they didn't. They brought them back for a 3rd scan at the 2-year mark. So a full year after the supervised lifting had stopped.
Which is genius because you want to know if the benefits actually stick around, right? Like if you stop the stimulus, does the brain just immediately go back to aging?
Exactly. Are these changes permanent or just transient?
Before we get to the results of those scans, we need to talk about the main thing this AI clock was measuring, the brain age gap, or BAG.
The BAG.
I like to think of it like a car. So chronological age is the year the car was manufactured. If it rolled off the lot in 1960, it's chronologically 66 years old today.
Right. You can't change that number.
Exactly. But the brain age is more like the mileage and the wear and tear on the engine. So the brain age gap is just the difference between the two.
That's a great analogy.
Yeah.
And in these neuroimaging studies, what you want is a negative brain age gap.
Because negative means younger.
Yes, a negative gap means your neural networks are functionally younger and more efficiently organized than your chronological age says they should be.
Like having a pristine engine in an older car?
Precisely. A positive gap would mean accelerated aging. So the big question was, can lifting heavy weights mathematically force that gap into negative territory?
Okay, so let's get into what actually happened. They start by looking for local hotspots in the brain, right? Like specific areas that changed.
Yeah, they started with a really granular voxel level analysis, basically breaking the 3D scan into microscopic cubes.
And the heavy resistance group, the HRT group, had this massive spike in connectivity.
A huge, highly significant increase. We're talking about a cluster of 8,517 voxels compared to the control group.
Which sounds like a lot, but the crazy part to me is where this activity was located. It wasn't just in the motocortex.
No, the overwhelming majority was in the prefrontal cortex and the superior parietal areas.
Right, so wait, what does this actually mean? If I do a bicep curl, am I just, like, flexing my prefrontal cortex?
Well, essentially, yes. I mean, the
Yeah.
prefrontal cortex regulates executive function, attention, complex problem solving, and the superior parietal area handles spatial orientation.
So lifting a barbell isn't just a meathead mechanical thing, it's a huge cognitive task.
Exactly. You're balancing a volatile load in 3D space. You're overriding your central nervous system, which is basically screaming at you to drop the heavy weight.
Wow, so that physical struggle is literally a workout for the executive control centers of your brain.
Right. But here's the mystery. When they looked at the moderate group, the MIT group, for those same local hotspots,
They found nothing, right?
yeah, no significant localized clusters compared to the control group at all.
So if a traditional radiologist was just looking for these localized hotspots, they would have said, oh, moderate exercise failed.
They absolutely would have. It would have been written
But
up.
we aren't using traditional methods. We have the AI brain clock.
Right. And localized hotspots only tell a fraction of the story.
So we have to zoom out to the whole brain network, the big reveal.
Exactly. When they fed all 6,670 functional connectivity features into the AI clock, looking at the entire global network of the brain,
Both exercise groups got younger.
they both reversed their biological brain age.
This is wild. Let's look at the hard numbers. At the 1-year mark, the heavy lifting group reduced their brain age gap by 1.42 years.
Right.
And the moderate group reduced theirs by 1.39 years. So they were basically tied.
Yes. Very similar results immediately after the intervention.
But the 2-year mark is where it gets crazy. A full year after they stopped the supervised program, the heavy group was 1.85 years younger.
Which is incredible on its own.
It is. But the moderate group, the people doing mostly home workouts, they were a staggering 2.26 years younger.
And the control group, obviously, saw absolutely zero significant change. They just kept aging normally.
So if we connect this to the bigger picture,
Well, we connect this to the bigger picture. Achieving a global age reversal of 1 to 2 years is highly clinically significant.
because aging isn't just an overnight thing.
Right, it's a gradual, cumulative process of cellular dysfunction. So turning back the clock by 2 years means preserving cognitive capacity and delaying neurodegeneration.
It's basically buying you 2 extra years of prime brain function.
Exactly. And the AI proved this was a global effect. It wasn't just the visual network or the default mode network. The entire brain achieved a younger state of operation.
Okay, here's where it gets really interesting, though. I have to play devil's advocate for a second.
Go for it.
The moderate group actually got slightly better long-term results, right?
Yeah.
2.26 years versus 1.85 for the heavy group.
Yes, they did.
But both groups got physically stronger legs. And when the researchers looked for a mathematical link between having stronger legs and having a younger brain,
They only found that correlation in the moderate group.
right, for the heavy lifters, there was zero correlation. Getting massively stronger legs did not mean getting an even younger brain. Why is that?
It comes down to something called the ceiling effect. It's a nonlinear dose response.
Meaning more isn't always better.
Exactly. Biological systems don't work like simple math. Doing twice as much intense exercise doesn't give you twice the brain benefit.
Oh, I see.
The paper actually brings up the weekend warrior concept. You know, people who do short, intense bursts of exercise on the weekend often get massive cardiovascular and cognitive benefits.
So you don't need to be grinding every single day.
Right. Once you hit a certain threshold of stimulus, your brain gets the signal it needs to adapt. Pushing way beyond that threshold, like the heavy group did, gives you bigger muscles, but the brain benefits plateau.
It's totally like charging a smartphone.
Oh, how so?
Well, if your phone is at like 20% battery and you plug it in, it charges super fast and efficiently. It jumps to 80% in no time.
Right. Very little energy wasted.
Yeah, that's the moderate group. Going from doing nothing to doing a couple of home workouts a week huge, rapid benefits.
That makes sense.
But if you try to push that battery from 80% to 100%, it takes way longer. The charger gets hot, it's less efficient, you're putting in way more energy for diminishing returns.
That is a perfect analogy. The heavy group applied maximum effort, but their neurobiology had basically already reached its saturation point for those benefits.
Okay, so bringing this back to you, the listener, moving from the lab in Denmark to your actual daily life.
Right, the practical takeaways.
You do not need to be a bodybuilder. You don't need to spend hours in some intimidating gym to protect your brain.
No, you really don't.
Yeah.
The takeaway here is that resistance training triggers systemic molecular changes.
It's an endocrine thing, right?
Yes. When your muscles struggle against resistance, they release myokines, these biochemical messengers, into your blood.
And those go straight to the brain.
Exactly. They cross the blood-brain barrier and trigger things like brain-derived neurotrophic factor, or BDNF, and vascular endothelial growth factor.
So you're literally bathing your brain in growth fertilizer.
Essentially, yes. It's a preventive lifestyle strategy. Even working out moderately at home, like that MIT group doing 2 home sessions, gives you lasting neurological youth.
It reorganizes the whole brain. That is just incredible. Okay, just to quickly recap for everyone.
Sure.
We looked at 309 older adults. We used an AI brain clock trained on thousands of scans. And we found proof that moderate and heavy resistance training can literally shave 1 to 2 years off your brain's biological age.
And those effects lasted a full year after the training stopped.
Right, which is the best news ever for anyone who works out at home.
Definitely. But, this raises an important question.
Oh, lay it on me.
Well, if lifting weights structurally rewires our whole brain connectivity, not just the motor networks, could the physical struggle of resistance training actually be training our brains to be more globally resilient to any form of stress?
Wait, like emotional stress?
Yeah, whether it's cognitive decline, emotional burnout, or just the information overload of the modern world. Is the barbell actually just a tool for whole brain plasticity and psychological armor?
Oh, wow. I love that. A barbell as psychological armor. That is something to think about during your next workout. Thank you all so much for joining us on this deep dive. Keep learning, keep questioning, and maybe pick up a dumbbell today. See you next time.